Hello, Gloria. How are you?
I'm fine, sir.
Good. Gloria, today I'm going to teach a very interesting section of physics, and this section is called as magnetism.
Yes, sir.
Now, Gloria, have you heard of magnetism before this?
Yes, sir.
Good. Since you know a little bit about magnetism, right, we are going to start with a very basic thing today, and this is called as bar magnets. Right? Suppose I take one bar magnet. Tell me, Gloria, a bar magnet contains how many poles?
Magnet contains two poles,
Right.
sir.
And these two poles are the North Pole and the South Pole. Right. Now suppose I don't like the South Pole. So I take a cutter, I cut it and I throw it. What will happen if it is separated? Nothing. Once again, this side will become South and the other side will become North. Let me give it one more try. Let me again cut this into 4 pieces. What will happen if it is cut into 4 pieces? Once again, nothing. This side will become South, this side becomes North, this side becomes South, and the other side becomes North. Now, if I take a big hammer, if I hammer this, if I powder this, if I grind it, then every small particle will have a North and a South. That means a magnet has to have a North Pole and a South Pole, and the two poles cannot be separated. After understanding this very basic property, right, let us go to the next property, and this is called as magnetic levitation, right. Levitation means to float, and when something floats because of magnetism, that is called as magnetic levitation. Now, how can something float because of magnetism? For this, let us understand this very simple principle. Suppose I take two magnets, and these two magnets are such that one magnet's North Pole and the other magnet's South Pole come close to each other, then tell me what will happen?
They will attract, sir.
You're right. They will attract, right? And this is called as attraction. On the other hand, if there are two magnets and these two magnets are brought close to each other such that the North Pole and the North Pole come close to each other, then tell me what will happen?
Sir, they will repel.
You're right. These two magnets will repel, and this is called as repulsion. That means when two like poles come, they repel. Now the same thing, if two magnets are kept above each other such that they repel, then what will happen is the magnet which is above will float, and this is called as levitation. Now what did the Japanese do? The Japanese used this principle of levitation between magnets, and they made an entire train, and this entire train floats in air.
Sir, really how it is possible for a train to float?
Yes, this entire train floats in air, and as this train floats in air, it is one of the fastest trains in the world because it does not touch the tracks, and hence there is no friction. And as there is no friction, this is one of the fastest trains in the world, which is called as maglev train.
So how can a train float?
Okay, so you want to understand how exactly can this train float? To make you understand this, I am going to perform a very small experiment for you. Okay, so now let us perform this experiment to understand how a train can actually float in air. For this, I take this magnet, and here I have another magnet. This is a disc magnet. Now when I have this particular disc magnet, I join these two magnets, they attract. You can see even when I turn this, the magnet does not fall down because there is power of attraction between them. Now what I'll do is, I will find one central position, and this is a central position where these two magnets will repel. Now let's see this. When these two magnets repel in this central position, you can see the magnet is repelling.
Wow!
Yes. The two magnets repel each other, and as they repel each other, the upper magnet is levitating. Gloria, this magnetism is a very powerful phenomena. Even if I take this pen and if I move this particular pen between the two magnets, still it is not affected. The magnetism is not affected by another medium which comes in between, right?
Sir, I have one question. What if a passenger sits on the train? Will train go down?
Okay. You're right, Gloria. If you are thinking that if a passenger actually sits on this particular train, then because of the weight of the passenger, the train should come down. So let us continue this experiment. Assume that this particular pen is the passenger, and I will put this passenger on the train and let us see if there is any effect. So I keep this pen on top of the magnet and let us see if the weight makes any difference. You can see it has not made any difference and the magnet did not come down.